You ever go online to look up a simple health question and you just fall down a rabbit hole of conflicting studies? One day coffee is a superfood, the next it's going to kill you. It's a mess. So how do we find what's real? How do we find the truth in all that noise? Well, today we're going to unpack a really powerful tool that science uses to do exactly that.
So the problem we're all facing is pretty straightforward. There's just a flood of research, an incredible amount of information being published every single day. For doctors, for people making policy, even just for us, trying to keep up is basically impossible.
And hey, don't just take my word for it. This is from the British Medical Journal. They said the people making these huge decisions are facing an overwhelming volume of research. We're not talking about a trickle of information. It's a fire hose.
Which, of course, brings us to the million-dollar question, right? If there are thousands of studies on one single topic, how in the world do you sort through all that to find out what's actually true? How do you separate the good stuff from the noise?
Well, luckily, the world of science came up with a really smart solution. Instead of looking at just one study at a time, they figured out a way to combine all the evidence into one single powerful super review.
The official name for this is a systematic review. Now, the key words here, you got to remember these, are explicit and systematic. This isn't just some casual summary. Oh no, it's a super rigorous scientific process designed to be as unbiased as possible.
You can almost think of it like a recipe for finding the truth. Step 1, you ask a super clear, focused question. Something like, does this specific drug work better than a sugar pill? Step 2, you go out and find every single study ever published on that question. And step 3, you carefully pull all the findings together to get that one big picture answer.
In this process, in theory, is amazing. It should give us the most reliable evidence there is. But you knew there was a but coming, right? There's a catch, and it's a pretty big one.
So here's the problem. Who's checking the checkers? If the super review itself is done poorly, or if they cut corners, then the whole thing is useless. We're right back where we started.
And this is the absolute crucial point. Not all reviews are created equal. If the researchers don't show us their recipe, if we can't see exactly what they did step by step, then we just can't trust their conclusion. A bad review is just as dangerous as a bad study.
And this slide just lays it out perfectly. On one side, you have a transparent review. They show you everything, it's clear, you could even do it yourself, and most importantly, it's trustworthy. But on the other side, you have a vague review. It's a total black box, the methods are hidden, and because of that, the results are completely unreliable.
So to fix this black box problem, the scientific community realized they had to do something big. They needed to create a universal standard, a way to guarantee transparency for everyone. What they needed, what we all needed, was a shared rulebook, a set of clear, non-negotiable rules that every single person doing one of these reviews had to follow. No exceptions.
And that entire rulebook, it all comes down to this one number, 27. That's it. 27 specific items that a review has to report on to be considered trustworthy.
And this rulebook has a name, PRISMA. It's basically that 27-point quality control checklist. It's a simple but powerful tool that forces researchers to be transparent and to show all of their work. It's designed to get rid of those black boxes for good.
So what's actually in this rulebook? What do these 27 items look like in the real world? Let's take a peek inside.
Let's go back to our recipe analogy. PRISMA is basically the standardized recipe card. It doesn't tell scientists what the final dish has to taste like, but it absolutely demands that they list every single ingredient and every single step they took to make it.
So here are just 3 examples from that list of 27. Number 1 is so simple but so important. The title has to say Systematic Review. Instantly, you know what you're reading. Number 2, and this is a big one, the full search strategy has to be published. I mean, every database they searched, every keyword they used. And number 3, they have to explain exactly how they checked each study for potential flaws or bias.
And here is what that first rule looks like out in the wild. See that title? And look at the last 3 words, a systematic review. Boom. Because of PRISMA, you know right away this isn't just one person's opinion. This is a comprehensive review, and you can and should hold it to a much higher standard.
Okay, so a checklist with a funny name is clearly a game changer for scientists. But why should the rest of us care? What does it actually mean for you and me?
Let's ask that question directly. Why is this important outside of a university or a research lab? Well, the answer gets right to the heart of the health advice and public policies that affect every single one of us.
The payoff from this is absolutely huge. When our leaders and doctors use reviews that follow the PRISMA checklist, they're building our health policies on a solid foundation of trust. It leads to better medical guidelines, smarter public policies, and just science that is more transparent, more complete, and more accurate for everybody.
So now you know the secret. You know about the rulebook. The next time you see a headline or hear someone say, well, studies show, a new little question might just pop into your head. Did the science behind that claim follow the checklist? It's a small question, but it makes all the difference.